Hello, my name is Janet Knodel. I'm the Extension Entomologist for North Dakota State University and located at Fargo, North Dakota. And today I'm going to provide an update for you on some of the field crop insect pest problems that we might be seeing in 2010, and specific topics will include insecticide efficacy studies conducted in 2008 and 2010, and then a little bit on regulations, Section 18s and EPA rulings, and then what IRAC is for you. It's an insecticide resource that's available on the web. And finally, protecting our pollinators, just a little bit about safety and when to apply insecticides to protect our important pollinators. Okay, for seed treatments, we did some testing on canola with a new seed treatment that they have coming out from Valent, clothianidin, for mainly control of flea beetles. We compared it to our standard Helix Extra from Syngenta Crop Protection to an untreated check as well. We had both a low and a high rate of clothianidin. And we did flea beetle damage ratings at different intervals, all the way from 23 days after planting to 37 days after planting. And then at the 37 days after planting, we also did a seedling vigor rating from 0 to 10. The yield is indicated in the line above the bars. As you can see, the experimentals, both the low and the high rate, were quite comparable to the Helix Extra in terms of efficacy. The damage ratings were similar and the vigor ratings. We can contrast that to the untreated check that had lower damage or higher damage ratings and a lower vigor rating. And in addition, the yield was lower than it was in the Helix and the two experimentals. The high rate of the experimental had the highest yield. And this chemical, I believe, will be released in 2010. Okay, weed stem sawfly was a major pest problem that we saw in western North Dakota this past year. And we feel that the sawfly is also spreading more east in North Dakota. The main injury is caused by the larvae tunneling internally in the stalk, interfering with the flow of nutrients and water to that developing head. As a result, you get a stunted head with few kernels and lower kernel weight. The tunneling also weakens the stem, and in turn you get lodging. This past year we saw anywhere from 20 to 50% yield loss, and in a few hot spots the yield loss was even as high as 80%. Sawfly infestation can also reduce protein content, so it's a very damaging pest. So many growers were asking questions about whether insecticides will control it. So we set out some trials at McCody and Hettinger. I'll only be showing you the McCody results today in central North Dakota. We used the Warrior insecticide for our foliar insecticide at 2.56 fluid ounces per acre. We had 2 applications timing, 4 to 6 leaf and flag leaf. We also had a seed treatment, Cruiser 5FS thiamethoxam. We used both the low and high rate that's commercially available for wheat. And then we used the seed treatment alone, and then we had a foliar on top of the seed treatment at the 4 to 6 leaf. We collected the wheat when it started to mature and change color and brought back 25 stems per plot and dissected these stems for injury caused by the sawfly larvae and also the larvae itself. We then looked at the percent stems infested. This is the data from 2008 at McCody. As you can see, there is no significant differences between any of the treatments. And also the yield did not fluctuate between any of the treatments, indicating that the insecticides, either seed treatment or foliar spray, did not control sawfly. For 2009, again, there was some differences that indicated we did get a lower percent stems infested from sawfly with some of the foliar sprays at the 6-leaf, flag leaf stage, and this one was applied on top of the low rate of the seed treatment. However, that did not translate into a higher yield, so we didn't get that money back in return. The differences in the yield that we see here is primarily due to the lack of a fungicide on that seed treatment. This here was an untreated seed with just the bare seed, so no seed treatment. So wherever we had that fungicide, it really did help increase the yield, but it was not due to sawfly. We also had a grower cooperator in Mott who used the variety Reader hybrid spring wheat in large strip trials, 25-acre strips with 3 reps. He had 2 treatments, sprayed and unsprayed, and he applied 3 different applications to those blocks. Early, mainly for wheat stem maggot, not for sawfly, and then when he felt he had peak sawfly flight, and then another one about 7 to 10 days later for the later sawfly flight. He used the compound Respect Zeta cypermethrin at 3 fluid ounces per acre. And here's the results from his trial. You could see we had twice as many percent infested stems in the unsprayed than we did the sprayed, so it did reduce the number of sawfly in the stem. However, we didn't really get a real increase in the yield. It was only three bushels more in the yield increase, which wouldn't pay for the cost of putting those 3 different insecticides on with the current value for wheat. And much of the southwest area looked like this in August and September. Much of the yield wheat had lodged due to the sawfly. So the bottom line is that the insecticides do not control sawfly, regardless of the treatment or the timing or how many applications you put on. We did not get control sawfly using insecticides, so we'll have to rely on other pest management strategies like the use of solid stem varieties like Mott and cultural control, planting date, for example, and crop rotation. Just a little bit review on soybean aphid on the threshold that's been adopted for the Midwest region. We are using the 250 aphids per plant on 80% of the plant as our economic threshold. It's important to remember that the threshold is an action threshold. It provides you with a 7-day lead time to get that insecticide on before you will see any yield loss. This threshold is good all the way up through the R5 growth stage of soybean, and it's applicable over a wide range of crop values and treatment cost. This research was conducted from 22 different experiments in 7 Midwestern states, including North Dakota and our neighboring states, South Dakota and Minnesota. I think the main problem people have with the threshold is its fairly large value. The aphids are very small aphids and difficult to count. So it's always advisable to pull up that whole plant and count all the aphids on the underside, the stem, and so forth, and not just the upper leaves. There's usually always some aphids I found when I've been doing my counting on the lower part of the plant, even though most of them will be concentrated on the upper region of the leaves early in the season. So here's some of our results from our insecticide efficacy study this year at Prosper. As you can see, here's our threshold at 250, and we never reached the threshold this past year. We averaged in the untreated check below 100 aphids per plant. We have several different chemicals that we tested. This is only a subset of all of the chemicals that we tested, a total of 30. So we have counts we did 7, 14, 21 days after treatment. As you can see, all the insecticides did very well and controlled the aphids all the way out through crop development. Leverage is a imidacloprid cyflothrin mix. Declare is gamma-salharthorine. Hero is zeta-cypermethrin and bifenthrin. Cobalt is chloriophos and gamma-cyharthorine. And bifenthrin is bifenthrin for the active ingredients. You can see they all did very well with the low pressures we were seeing this last year. But if we take a look here at the yield, you can see it fluctuated a little bit, but there was no significant differences between any of the treatments in yield. And this is good information. It shows that if you do spray an average of 100 aphids per plant, even though those aphids were in there at 100 aphids per plant all the way from R5 through R6, R4, we still didn't see a yield difference. So those of you that are spraying at 100 aphids per plant, you're going too early. You're knocking out the beneficial insects, which are keeping the aphid in check. Here's some more information from Minnesota on the same type of study, except they added seed treatment and fungicide and an early application of insecticide at V3. You can see here where they did the timing treatment with the R3 and then the economic threshold treatment. They were both applied in the same time period, 8 August 2nd here and then July 29th. So they're essentially the same. If you follow the lines out, you can see that later on in the season, the populations of aphids did not resurge in the economic threshold or the R3 treatments. But in those treatments where we had just the seed treatment alone or fungicide alone or a early applied insecticide, this line here that is kind of pinkish, the population of aphids resurged, and of course the untreated check. And this is primarily due with especially that early insecticide application that you're putting out for the same timing as you are for your weed control. You're knocking out the beneficials that keep the aphids below the threshold early on in the season. So timing and when you spray for aphid is very critical. You don't want to go in too early to disrupt the natural enemies. Here you can see the yields from the different treatments. Basically, the bottom line is anything that was sprayed near the economic threshold level was the highest yielding and resulted in significantly higher yields than the other treatments. And the bottom line is here, don't apply a fungicide unless you need it. Don't apply an early insecticide. Seed treatments do not work for control of aphids because our soybean aphid typically comes into North Dakota too late for that seed treatment residual, the insecticide part, to be effective on controlling aphids. If we look at some of the economics, you can see if we did go with that intensive approach where we're using seed treatment, fungicide, and insecticide, it would cost us anywhere from $30 to $35 per acre. And you can see the breakdown there. It's 10 to 12 for the seed treatment, 14 for the fungicide, 10 for the foliar insecticide. If we go with just the IPM protocol, for scouting, $6 to $7 an acre, and crop consultants have told me that that's high. They make maybe $3 an acre, and then $10 for that foliar insecticide. That's a $15 different. So if you had a field that was 500 acres of soybeans, you're going to get a savings of about $8,000 just for that one field if you use the IPM strategy. DuPont has an interesting new chemical out, the Coragen, for control of Colorado potato beetle. This is a new mode of action that is completely different from the other chemicals for control of Colorado potato beetle. And this is especially important for Colorado potato beetle because it does have the potential for developing insecticide resistance. And we are starting to see some problems with Admire Pro, which is our standard right now for control of Colorado potato beetle. Here's some of our efficacy trials for our Colorado potato beetle insecticide study at Glendon. You can see here we had Coragen at both a low and a high rate. Here's the low rate at 3.5 fluid ounces per acre and the high rate at 5 fluid ounces. Again, this is just a subset of the total insecticides tested. Ryman is a novaluron, which is an inhibitor of chitin biosynthesis. And Temprano is avamectin, which is a chloride channel activator. And then our standard Admire Pro. As you can see, all the insecticides did quite well in reducing the number of small and large larvae compared to the untreated check. And this particular site we do our insecticide study at has very high pressures for Colorado potato beetle. This one was at 7 days after treatment. And this one was at 21 days after treatment to take a look at residual. And you can see most of the insecticides kept their residual, and except the Temprano, which is the avamectin. For insecticide regulations, it's important to be familiar with what has happened with Furadan from FMC, carbofuran. It was revoked, the tolerance. So basically due to human safety issues, especially with children, and dietary exposure to carbofuran in the water and food, it was found to be not too high of a residual. So we can't apply Furadan anymore to any of the food crops after December 31st, 2009. The FMC, National Sunflower Association, National Potato Council, and the National Corn Grower Association has filed a complaint, but it was revoked. The EPA decided to revoke all the pesticide tolerances, and they denied the objection. This impacts quite a few different crops in North Dakota: barley, corn, wheat, or barley, corn, oats, potato, pea, sugar beets, soybeans, sunflower, and wheat. However, sunflower is the one I'm mainly concerned with. We used Furadan for control of the sunflower stem weevil, and we will no longer have that chemical anymore. There are no replacements for stem weevil control in sunflower that work. So that's something that entomologists are working on. And fortunately, the sunflower stem weevil hasn't been a major problem in North Dakota over the last several years, but it has been a problem in the more central states like Kansas. Section 18, last year we had Hivestan for control of varroa mite in beehives, and you can see I put a red circle around the varroa mite on the honeybee there on the right. For IR4 food use, this involves minor use crops primarily and helps get pesticides registered on minor use crops. An A priority insecticide for this next year is on dry beans is flunicamid. Flunicamid is a homopteran feeding blocker, so it'll be primarily effective on like pea aphids and potato leafhopper on dry beans. Also on the list there's repellents for the pheasant that we got for corn this past year. It's also being applied for canola and sunflower, anthraquinone. Okay, a little bit about ARAC. It's Insecticide Resistance Action Committee, and you can find information on insecticides on this website. Some of the information is you can find the group of insecticides listed, and then also the chemical class, and then the active ingredient. And then you can also get information about a specific insecticide mode of action, the pest and crops that it will be registered on, and use patterns, and the chemical structure of the pesticide as well. Finally, we're going to end here with a little bit about protecting our pollinators while using pesticide. There is an alarming increase in the number of bee kills with the spraying for pesticides. So it's important to protect our bees. They're very valuable for seed set and fruit production in many crops. Some of the crops in North Dakota that benefit are canola, pumpkin squash, sunflower, wildflowers, clover, and alfalfa. But if you're planning to spray and your crop is flowering, you should always be aware of where the hives are in your area. Bees can fly quite a distance, over 2.5 miles, when they're foraging for food. And they can be exposed to pesticides either directly, from a mishap and the hive gets sprayed, or when they're foraging in the crop, or drift off the crop to non-target crops like weeds in the ditch that might be blooming. So it's very careful to protect our pollinators and try to be careful. You can find out where the bees are located in North Dakota and then communicate with your beekeepers so they can maybe move the bees out of the area or cover them up. Just go to the North Dakota Department of Agriculture website there listed, and there's a listing of all the beekeepers in North Dakota. It's a requirement or ruling here in the state. You can also choose a pesticide with low toxicity or residue, and also spray when the bees aren't actively foraging, which is in the evening or early morning. And that's usually when the wind isn't blowing as well. So a lot of our insecticide applications already go out in the early morning or evening when the wind isn't spraying. And for some insects, it's actually beneficial to spray in the evening after the sun is set, like wheat midge or cutworms, because that's when they're active. Again, just be aware of the problem we have with spray drift onto other crops. that may expose the bees to pesticides. If you'd like more information on native pollinator conservation and bee conservation, you can go to the Xerces website listed there at the bottom. Thank you very much, and I'd like to thank Pat Bouzet and Mark Botel for their assistance with the insect guide and insecticide studies this past year. And thank you very much, and have a good day.